Page 162, lesson 3.1, continuation here. Relation is a function if each input corresponds to exactly one output. You can use an arrow diagram or table to determine whether the relation is a function. So this one, you can see each input is going just to one output. The 1 just goes to one number. The 3 just goes to one number. The 8 just goes to one number, and so on. This one, they've given us a table. It's not a function because, remember, the inputs, like our x values, we have two different x values of 2, but they're going to two different numbers, going to 4 and going to 6. So that's like if we have the same ingredients, but we end up with two different things. You know, I can't have the same ingredients and it makes cookies and meatloaf. That doesn't make sense. So that is not a function. So do you know how? They're asking whether these are functions or not. So if you look on number 4, we can see the 5 just goes to one number. The 10 just goes to one number. The 15 just goes to one number. The 20 is going to two different numbers. So that is not going to be a function. So again, input of 20 has two different outputs, so that's not going to be a function. Number 5, is this a function? So we can see, if you look at this, all the inputs are different, and so we're actually going to be okay here. So we could say, yes, each input has only one output. And then number 6, look at your x's first of all. So altogether we've got a 1, 2, 3, 4, 5, 6. And so yes, that would be a function also. Basically, we could just take our exact answer from number 5. Okay, and again, if all the x's are different, I'm not even going to look at what the y's are. All the x's are different, I'm okay. It's a function. Okay, if they have the same, you know, two x's have the same y, like if I have a 4, 5 and a 4, 9, for example, or sorry, 4, 5 and 7, 5. Okay, those are different x values, so that's okay. You know, it's like this is making oatmeal cookies, this is making peanut butter cookies. If, let's say, 5 just says is cookies, so it makes cookies, okay? Just think of it as a non-specific thing there. You know, the problem is if I have a 7, 5 and a 7, 9 or something like that, that does not work, because that's the same x, the same ingredients, can't make two different things. Workbook page 39, number 1. We have a set of ordered pairs that represents a relation. And they want us to make an arrow diagram that represents the relation. So we're going to make two kind of ovals here. And usually the first one will be our x and the second one will be our y. And then a lot of times they'll try to put these in order. So I'm going to just try to put these in order if I can. X values, lowest x value is a 1. There's another one, but I don't need to put it twice on this arrow diagram. There's a 2. There's 2 3s, and there's a 6. So those are my x values. Now if we look at the y values, lowest y value is a 4. We've got a 5, a 6, a 7, an 8, and an 11. And then what we're going to do then is we're going to draw arrows to make these points. So the first point is 1, 7. So we're going to draw a line from the 1 to the 7. Put an arrow on the end. 3, 8. 3, 6. 6, 5. 2, 11. 1, 4. So we end up with kind of a jumbled mess here, it looks like. So if that's too confusing to look at, you can go back and look at the original points if you want. For part B, it asks if it's a function, and the answer is no. And we could say something like no, because there is more than one output for the inputs of 1 and 3. And even if one of them doesn't work, even if one of the inputs has more than one output, already that's enough for it not to be a function. So this one is not a function, 2 reasons. Number 5, set of ordered pairs. 1, 8, 50, 3, 30, 5, 50, 5, 42, 50, 6, 51, 7, 59, 50. Represents the cost of tickets for the school play for different numbers of tickets. The input represents the number of tickets, and the output represents the total cost. Is the cost a function of a number of tickets? And explain. So inputs are X, outputs are Y. Basically, the question is more or less for this problem, if you buy a certain number of tickets, is there just one cost for that? So if you look at all the numbers here, 1 ticket, 3 tickets, 5 tickets, 6 tickets, 7 tickets, all the ticket numbers are even different. So for sure we're not going to have an issue of, having the same X but then having 2 different Y's, because we don't even see the same X value happen twice here. So we could say, yes, it is a function, because for each number of tickets, there is exactly one total cost. Number 9, they want us to tell which of these relations are functions. Select all that apply. So there could be more than one option. So which are functions? So again, first thing I would probably do is look at the X values, see if you have any repeated X values. And then if you have any repeated X values, just make sure then if they have 2 different Y values, or if it's just the same exact point repeated. If it's the same X but 2 different Y's, that's the case where it's not a function. Remember, that's like our same ingredients can't make 2 different things when we get it out of the oven. We know based off the ingredients what we're going to get whenever it's done. So on the first one, we do have 2 repeated X values. We have 2 6s here. 1 6, the Y value is 8. 1 6, the Y value is 10. So that's the same X but 2 different Y's. So that is not a function, so we will not put a check by that one. The second one, similar story here. If you look at all these, we have 2 X values that are 8, and the one goes to 29, the one goes to 39. So that's not going to work, not a function. The third one, they're probably trying to trick us up here, but it's not going to work. Look at your X values. X values are all different. If the X values are all different, it doesn't even matter what the Y values are. It's a function. Yes, the Y values are all 4. That's okay. It's a function. Okay, consider this like we talked about yesterday, was that this could be like a case of having, we're making different types of cookies. So we make peanut butter cookies, we make oatmeal cookies, we make chocolate chip cookies, whatever they are. So it's different ingredients, but then generically we can say they all make cookies. Okay, let's say 4 represents cookies. All right. So that is a function then. Last one, same thing. This has all different x values. In fact, the y values are all different here anyway too. But again, different x values, we don't even need to look any further. That is a function. So this gives you an idea about how to work with relations and functions.